Hi students, today we are going to discuss N-Kuhn's problem. This N-Kuhn's problem is an application of backtracking method. So we are going to do this problem using backtracking method, okay? So N-Kuhn's problem is a problem that places a Kuhn on an N into N chessboard so that no two Kuhns attack each other. If you have played chess, you know the movement of a Kuhn in the chessboard. When does it attack each other? The two Kuhns attack each other when they are in the same row, same column, or in the diagonal. So here the rule is that no two Kuhns, no two of them are on the same row, same column, or same diagonal. So N-Kuhn's problem we are going to discuss 4 Kuhn's problem and 8 Kuhn's problem. Okay, let us see how 4 Kuhn's problem work. So we'll see what is a 4 Kuhn's problem. The 4 Kuhn's problem will be consisting of 4 Kuhn Q1 to Q4 and it will be placed in 4 into 4 chessboard. Now we'll see how these Kuhns will be placed in this chessboard so that they don't attack each other. So let us start placing it, okay? So let us place the Q1 over here, the first slot. So Q1 is placed here. Next in box, I'm going to place Q2. Can you place Q2 here? No. Can you place here? No. Can you place here? Yes, you can place here Q2. Okay. Now, you have to place Q3. So Q1 is placed here. Q2 is placed here. Now place Q3. Can you place Q3 over here? No. Can you place here? No. Can you place here? No. Here? No. So what you have to do is you have to backtrack. Okay. You will have to backtrack. So when you backtrack, so Q2 is backtracked to here. What will happen? So it will reach here. The Q2 will reach here. Q1 is the same. Now let us check. Can you place Q3 here? No. Can you place here? Yeah. You can place Q3 here. Okay. Now let us check. Can you place Q4? Can you place Q4 here? No. Can you place here? No. Can you place here? No. Because diagonal is coming. Q3 diagonal is coming. No. Can you place here? No. So what you have to do? You have to backtrack. Can you backtrack here? If you backtrack Q3, no, there won't be any benefit. So again you will have to backtrack. If you backtrack Q2 also, that is not useful. Then what you do is you will backtrack Q1. Okay. So let us backtrack Q1 and write the Q1 at the second place. Q1. Now let us check. How can you keep Q? So we have written Q1 here. Now let us check where you can keep Q2. Can you keep Q2 here? No. Can you keep here? No. Here? No. Here? Yeah. You can keep Q2 here. Then what about Q3? Q3 can be placed here. Okay. Now what about Q4? Can you place Q4 here? No. Here? No. Here? Yeah. You can place Q4 here. So this is the solution for 4 Kuhn's problem. So 4 Kuhn's problem may have more solutions also. You can check it by yourself. So one solution I am going to write here. So the solution 1 is 2, which is the position here 4, next position 1, next position 3. This is the solution 1. One more solution I am going to tell you is 3, 1, 4, 2. That you can check. 3, 1, 4, 2. Okay. If you are finished with 4 Kuhn problem, you can do 8 Kuhn problem. Here 8 Kuhn problem will be having 8 Kuhns and 8 into 8 chessboard. Okay. So I have drawn 8 into 8 chessboard here. Let us check where can you place Q1 now. So you can place Q1 here. Yeah. Can you place Q2 here? No. Here? No. Here you can place Q2. No. So you can place Q2. Next, can you place Q3 here? No. Here? No. Here? No. Here? No. So you can place Q3 here. So what about the fourth one? Can you place here? No. Can you place here? Yeah, you can place here. What about Q5? Can you place here? No. Can you place here? No. Can you place here? No. Can you place here? So you can place here Q5. So next you have to place Q6. Can you place here? No. Here, no. Here, no. Here, no. Here, no. So you can't place Q6 anywhere. Now what you have to do is you have to backtrack. You have to backtrack. And when you're backtracking, you can see the another place where you can keep your Q5. You can keep your Q5 here, no? So this can be omitted and you can place Q5 here. Okay. Then also you check whether you can place Q6. Here, no. Here, no. Here, no. Here, you can place Q6, no? So you can place Q6 over here. You can place Q6 over here. Let us check whether you can place Q7 over here. No. You can place here? No. Here, no. Here, no. Here, no. Here, no. No. Here, can you place? Yeah, you can place Q7 here. What about Q8? Can you place here? No. Here, no. Here, no. Here, no. Here, no. Here, no. What about here? No. Here, no. Though you have to, so you will have to backtrack. After all the backtracking, you can, as we have done in 4Q problem, you will be getting like this. So the solution one can be 3627148 and there can be one more solution. There can be more solution for this. So that can be 1586372 Okay. Let us check the algorithm for n-Qunes problem, where k is the kth quene I want to place and n is a number of queens. And here, let us check how this algorithm is working. For I is equal to 1 to n, you have to do what all things. N is the number of queue. Okay. And if this function is true, then you have to place the queue. If k is equal to n, means that you are going to place a last queue. Then if you have placed the last queue, then you have to print that array. That is, we have already printed, no, like this 3627148 So you have to print that x. You have to print that x array from 1 to n. Else you have to go for n-Qunes problem from k plus 1 comma n. Now we are going to draw a state space tree for 4Qunes problem. It's very important question because it's asked in all question papers. So first we consider the case where n is equal to 4. It's a 4Qunes problem. So n is taken as 4. A permutation tree or state space tree shows all possible elements in the solution space. So here how many leaves will be there for this tree is 4 factorial, which will be 24 leaves will be there for this tree. First, these nodes are labeled in depth first search ordering. Okay, so we'll start drawing the state space tree. So it's a state space tree. So first I will have a root. In some textbook it will be written as 1. So here how many columns are there? Okay, if it is a 4 by 4 matrix, you will have 4 columns and 4 rows. So there how many columns are there? That will be represented here. 1, 2, 3 and 4. 4 columns will be there. Okay. Now you can place Q1 here, 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 here. So here we are not considering any implicit constraint, any constraints. So first we are going to place Q1 here. So x1 is your Q1. x1 can be placed in the first column, x1 can be placed in the second column, x1 can be placed in the third column, x1 can be placed in the 4 columns. Okay. Next, if you are using x1 to be placed in the first column, then you have to consider this node. If you are taking the second one, you have to consider this node. And if you are taking this one, you have to consider this node. And if you are taking this one, you have to consider this node. Okay. Now, if you are considering x1 if you are considering the quune in the first column, then where all you can place your Q2. Q2 can be placed here, or can be placed here. Suppose I am going to place Q2 over here. How can you represent this? So this can be represented by X2. X2 can be 2. This is the second node. So 2. X2 can be 3. And X2 can be 4. Fine. Now, if you are considering this will be the node. If you are considering this will be the node. And if you are considering this will be the node. Okay. Now we are going to place Q3. So you have placed Q1 here in the first column, Q2 in the second column. Now we are going to place Q3. Now these are the two places you can fill Q3. So I am going to fill here Q3. So here X3 is equal to 3. Here X3 is equal to 4. So you can place here or here. Now I am going to place Q3 here. So this node has to be considered, and if you are taking the fourth position, this node can be considered. Now, which position is left behind to place 4? To place Q4. Now this position is left behind. So I am going to place Q4 here. Now Q4. Now X4 is equal to 4. And if you are considering this is the node. Okay. Now what you will do is, if this is not the condition, so what you will do, we will backtrack here. Again you will backtrack here. Then if X1 you are put inside first column, X2 is second column, X3 are placed in the fourth column. Now you can place X4 in the third column. Okay. Then you can backtrack here. You can again backtrack here. Now you can fill up all these values. Okay. So after filling the state space tree, it will look like this. Okay. Now you can check how many leaves are there. So we have 24 leaves here. Okay. Now what you have to do is, you start numbering this node. So this is 1, this is 2, 3, 4, 5. Now we are going to backtrack now to here. So we'll reach here. So this will be 6. So this will be 6. This will be 7. Then after this, where you will go? You will go here. So this node has to be visited, no? So that will be 8, 9, 10. So after backtracking, you will reach here, and then one node has to be visited, that is 11 and 12. Now we have to backtrack. We'll go here, here. When you reach here, one node is not been visited. That is, this node is visited next, then this node, then this node. Then you have to backtrack. You will get this node and backtrack. Then you will visit this node and this node. Then finally you will backtrack here, 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 then here. When you reach here, which one is not been selected? Then this one is not selected. Okay. That is this node. When you reach here, this node is not been visited. So you will visit this, then this. The same procedure is continued. Let us check the solution. Now from the state space tree, let us check where all the solution exists. That is 3 here. That is, first node is, the first quune is placed in the third column, then first, then it is placed on the fourth, then it's placed on the second. This is your solution 1. Solution 2 is 2, then it should go to 4, then 1, then 3. Students, I hope you have understood what I've taught now. Thank you for watching my video.